Hello, everybody. My name is Logan Steese, and this is the final report for CYB 508. Had coffee at an unruly hour, so I may seem extremely excited. So, my report is anomaly detection and credit card transactional data, and I just took a little deeper dive into one of our assignments. So, what is anomaly detection? First off, it's any process in which you can identify any sort of outlier or unusual observation. And the cool thing about anomaly detection is that, with in today's age, everyone thinks machine learning and whatnot, but it can also be not even requiring a computer. Think of like if you're an assembly line worker, and you're powder coating wheels or something, and you notice this wheel has an extra lug bolt hole. You've detected an anomaly and you got to do something. Or say you work in a sewing shop and a shirt has 3 sleeves. That is an anomaly. With the progression of technology, we've just begun to start associating anomalies and detecting them with machine learning and everything cybersecurity related. So first off, we have to before we get into all this, we have to understand what is passed with credit card transactional information. So the standard stuff, your credit card number, your full address of wherever your billing address is, the 3-digit code on the back, expiration date, as well as the amount. Now, depending on if it's a online purchase or an in-store purchase, you've got things of maybe like the store full address, so state, street, zip code, maybe even country. You can have the IP address, you could have the classification of the merchant, and I'm sure there's some EMV parameter security information that's passed along to the processor, and that's the stuff that deals with the chip. So now that we know a little bit about what's passed with a credit card transaction, let's kind of take a look at this data set. So we had 31 columns. 3 of them were able to be understood by a human. We've got time, amount, and class. Okay. So V1 to V28 are just random columns. We can't understand this. And the reason why is because this data set is part of a transactional history. Okay. And with PCI compliance, you can't necessarily just publish that. But what you're looking at, V1, V2, V3, and all those columns is they're encoded information. So what happens is when you have a data set, so like Logan Steese goes to swipe his credit card, it's got the time, it's got the state, it's got all that information we just talked about on the last slide. A machine learning algorithm can't necessarily understand that. So you have to run a function, generally like a one-time encoder, to convert that information into a numeric value that it can understand. So like say North Carolina is going to represent the value of 0.166480 and so forth. So it's safe to assume that all of this data is just encoded information that we went over on the last slide. Okay. So as I started to do my analysis, I noticed something quite interesting, and here's a breakdown of all of the columns, or just a couple of them. But we can see that there is a rather high ratio of imbalanced data. So 99.8% of the data has a specific value, and there's only 2 values. So when I started to do my analysis, which I'll go over in the next slide, this was a big thing that I had to take into consideration. So I applied 4 algorithms: logistic regression, random forest generator, decision tree, as well as k-nearest neighbor. On the left-hand side, what we're looking at is a function or an algorithm that was used with a specific accuracy metric. So on the left-hand side, the metric to measure all those percentages was accuracy. All right. And I knew pretty much almost immediately that something was off, just because those are very good percentages. And if I was a statistical analysis person, I would be approaching every credit card processor ever. On the right hand side, what you see is a accuracy measuring function that is able to compensate and handle imbalanced ratios of data. Now, I thought it was very eye-opening that when we measure k nearest neighbor, just your standard accuracy metric, we get 99.85. And then on the right-hand side, when we compensate for the imbalanced data, we get 7.08%. That is a huge difference. That's not even a little bit. That's astronomical. So a couple conclusions that I learned throughout this research project is, one, knowing the importance of your data. Like I said before, we had all those columns, and unless you had any idea what you were looking at prior, it's almost impossible to tell. And even though that we don't know for sure what that data was because of the type of data it is, we can only assume that some of that is, information that's being passed for a credit card transaction. The second thing is using the correct metric to measure accuracy in those percentages. I mean, like you saw before, those percentage differences were astronomical. All right. And now lastly, the whole anomaly detection thing, how would we implement this? So what we do is, let me go back a couple slides. So there's a function called predict that's a part of the whole, I forget, functions that we were using to measure accuracy and whatnot. All we would necessarily have to do is we would have to take a transaction, and all of this information, we'd have to put it in, send it through and pass all of these parameters to it. And because we'll use the decision tree, we pass it and it'll return a number, generally in the form of an array. But fortunately here, that array is just going to be class, and it's going to be 0 or 1. So we would pass all this data, all these columns, and it would return a 0 or 1. Now, one final conclusion is that if I were approaching a credit card processor, these numbers right here, 46, 74, and 7, in my opinion, are not accurate enough to rely on these algorithms. So with this data set, I don't think that we can trust these algorithms, and further manipulation of the data or other algorithms need to be explored, because 75% is just not good enough for me, especially like say if someone goes to purchase a Lambo, that's $250,000. I couldn't imagine a business trying to eat that if that transaction was fraudulent. So my name is Logan Steese. It's been a fun semester. I hope you learned as much as I did. I will see you in the next class.